Okay, so hello guys, welcome to Cloud Native Live. So where we dive into the code behind Cloud Native. So I'm Shariat. So I'm a Sensitive ambassador. So I will be your host, right? So every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. They will build things, they will bake things, and basically they are going to talk about the Cloud Native stuffs. In today's session, I'm stoked to introduce Stephen. I'm stoked to introduce Vishal and Anusha, both here to talk about a Kyverno server, report server. So this is an official live stream of CNCF and as such is subject to the CNCF code of conduct. So please do not add anything to the chat or question that would be in violation of the code of conduct. So basically, please be respectful of all of your fellow participants and presenters. So with that, I will hand it over to Anusha and Vishal. So let's add them to the stream. So, hey Anusha, hey Vishal, how are you?
Yep, doing good. Thanks, Nitin. How
Yeah,
are you
thank
doing?
you so much. Yeah, I'm fine too as well. Okay, so I think you guys can like start by introducing yourself, and we can start the session, right?
Yeah, sure. Hi, everyone. I'm Anusha. I'm a product manager at Nirmata. I've been at Nirmata for about 2 years now, and I manage Enterprise Kyverno and the our flagship product, which is the Nirmata Policy Manager. Happy to be on this live stream.
Yeah. Hi, folks. I'm Vishal. I am a maintainer of Kyverno, and I have also worked at Nirmata as a software developer, and I usually just maintain Kyverno and subsidiary projects.
Awesome. So yeah, let's get started, right?
Okay, right. Let me share my screen. Okay, I hope that's visible. Cool. So we are here today to talk about Kyverno's newest feature, which is a report server, which was released in Kyverno 1.12. So this is a new approach to policy report management. So for those of you who have been following Kyverno for a while or have been using Kyverno, you must be aware of, overwhelming HCD issues that come in, large or busy clusters in Kyverno, and the report server is a solution to all of those problems. So we are here today to explain the problem, that was there, which led to the development of report server. And Vishal would be talking about the architecture, and we'll also be showing a cool demo on how this works. And we'll end with, if you want to run report server in production, or if you want to just play around with it, what are the possibilities and how you can, get started with it. So moving on. So we already introduced ourselves. I'm Anusha, and I have my co-presenter Vishal. And this is the agenda. We'll start with even what is policy reports, what it means and what is the adoption of policy reports in the community today. Why do we need report server? We'll do a deep dive into its architecture and demo, and then end with production best practices. So in the meantime, if there are any questions, feel free to drop in the chat. If I'm presenting, Vishal would be able to answer that and vice versa. So feel free to ask us any questions anytime. So what is the problem statement? Let's start with, why are we even here today? So let's start with what is a policy report. A policy report, it's an API. It was developed under the Kubernetes policy working group. It provides an API, a standard API format that can be used by any policy engine, security scanners, or any other security and compliance tools that wants to either produce or consume policy results. It could be security findings or any other form of, say, compliance reports for different cluster resources. So the advantage of this is that you're using a standard API format, so all your tools are speaking the same language. And if you want to build abstractions on top of it, for example, if you want to build different UIs or dashboards, it becomes very simple. And since this is a policy report is a CRD, the reports that are generated are also resources in the cluster. So your cluster becomes the source of truth, and it gives quick feedback for developers. So it is as simple as doing kubectl get policy reports, and you would be able to see all the reports in your cluster itself. So that is why policy report API is very convenient for developers to even consume and for building further abstractions. And even though this was started as a project under the policy working group, we now have a KEP open to promote this API into a Kubernetes SIG API. So with this, we can get more community adoption, more contribution from users, just hoping that we build a healthy ecosystem around the policy report API. So there are more details in this KEP, so feel free to go ahead and take a look. So coming on to who are the users of policy report. So we have leading policy engines like Kyverno, which generates reports in the policy report API format, and tools like Kubebench. Although Kubebench generates report in a different format, we have an adapter for it that helps convert the Kubebench output into policy report API format. And similarly, Trivi, JS Policy, and other open source projects. And not just that, there are enterprises also using this policy report API, like the Nirmata Policy Manager from Nirmata. Even open cluster management projects use the policy report API. I can talk for Nirmata Policy Manager. So at Nirmata, we use this policy report API format to generate policy reports, compliance reports, and this helps us. And because we stick to this standard format, it helps us build different kinds of dashboards pretty quickly. So it is super useful and helpful for us. There's a complete list of adopters in the KEP summary, so you can take a look. I just put a few of them over here. Coming to the actual problem, now that we know what a policy report API is and the benefits of it, we should understand what is causing the issue that we had to develop a report server. So like I said in the beginning, if you are using Kyverno for some time now, you should have seen this in the community. Sorry, okay. You should have seen this in the community where discussions around the policy reports being piled up and they're causing bottlenecks in HCD, which in turn increases latency with the API server. And in even extreme cases, it brings the cluster down as well. So I've just linked, put screenshots of a couple of issues over here. So here you can see admission reports piled up, causing HCD turned into read-only mode. So we've seen such issues both with our community users and also with our enterprise customers at Nirmata. And just to give some more context around this, why this happens, one of the reasons is the way reports are generated in Kyverno is that for every resource and for every policy rule that you have, Kyverno generates a report for it. And every time the resource gets updated or recreated, the report also is updated. And also for something like, say, a deployment, Kyverno has this capability of auto-generating rules for replica sets and pods. So what this means is now reports are also generated not just for your deployment, but also for replica sets and pods. So quickly this starts, multiplying. And if you have busy clusters where you have either, large number of pods running, or you're constantly recreating your resources, or your pod is recreating for some reason, these reports start piling up. Although these reports are almost cleaned up, the stale reports are cleaned up immediately, there are situations where there's a sudden spike and your cluster just stops responding. And in those situations, you have to just just to recover, you may have to even bring down Kyverno. But to avoid all that, the Kyverno communities, we started brainstorming on solutions on how can we mitigate this problem. And there are several options that were considered. I'm going to just present a few of those over here. Okay. So what are the different options? So if you run into this issue, what options do you have?
Anusha, I think your
Yeah.
screen somehow got like not. It's not shared
Oh,
right now.
is it?
Yeah,
Okay.
yeah. Now
Do you see
it's
it now? Okay. Yeah. So if you are using Kyverno and if you run into this issue, so let's consider what are your options, right? One of the options is to increase HCD itself. I think I should have mentioned that HCD comes with a limitation of having 8 GB of storage, and this is not just for your policy reports, but this is for all of your resource in the cluster. So obviously, one option is you add another HCD instance so that you can now handle or process more reports. But think about it, right? Now you have to manage this whole new instance. You'll have to, it's a maintenance overhead. And it's also possible that there's only a short period of time, there's a spike and you might have needed additional storage. But you are stuck with this additional instance, you have to manage it. So what is the other option? The other option is to reduce the reporting activity itself. So this is equivalent to saying, Kyverno has capabilities where you can filter namespaces which you actually want the reports to generate in. You can include namespaces, or you can exclude certain namespaces. Similarly, you can say, I'm interested only in certain kinds of deployments. Well, this acts as a stopgap solution. Sure, you are reducing the number of reports that are generated, um, but that's not a permanent feasible solution, right? Because we are telling you, uh, don't use policies in all of the namespaces. We are kind of creating those security backdoors, and your namespaces that are not guarded by policies and rules now are vulnerable to attacks. So this is, while a stopgap solution, works, but not intended for long time. And then we discussed a third option, you know going to the root cause of, like, what is causing this issue. One is, overloading HCD because of the limited storage, and then HCD in turn causes latencies in the API server. So what if we take this reporting activity away from HCD and API server? Now, if you look at policy reports, they do not need HCD guarantees. So HCD has strong consistency, high availability, all the guarantees that it provides for other Kubernetes resources, and even distributed systems in general. These reports do not need that kind of guarantees. Suppose, say, if a report is deleted, you can always recreate a report, and the intention of this report is to reflect the current state of the cluster, like whether a deployment is configured correctly or not. So uh, it is okay to not have those strong consistency HCD guarantees. And it also means, if you're now not using HCD, you are not overloading or not overwhelming HCD, which means your API server can be performant as well. So the the idea started from, we need something else other than HCD for storing these reports. And it means we can still continue to use the policy report API. We don't have to abandon the API, but we still get all the goodness of policy report API, while not overwhelming our HCD and API server. So this is how report server came into being. There is a KDP for it, and Vishal has worked on it extensively, so he's going to take it here from now. Yeah, over to you,
Right.
Vishal.
Let me share my screen. Um, yeah. So to solve the problems that Anusha mentioned previously, we at Kyverno have created a new sub-project called the report server, which can be used to improve the performance of a large-scale cluster by taking the load of reporting away from HCD and the API server, right? So how report server works is that it basically takes all the requests for um, policy reports from the API server using Kubernetes API aggregation layer, and then handles it themselves to store it in a separate store it in a separate database that can be either in cluster or outside of the cluster either. So how this works is that Kubernetes provides a feature called API aggregation layer, which is basically a way to extend the Kubernetes API beyond its core capabilities. And we can use it by creating a custom resource called the API service. And once it is created, what happens is that all the requests for a specific URL path that you claimed using the API service will go to your specified server, and then that server can do whatever it wants with that API request, right? So a report server basically creates the same API services for policy reports custom resource, and then it handles all of them by storing them in a database that is um, outside of etcd, right? So in this slide, so what reports are basically is that it's a scalable solution to store policy reports in an alternate database, and it uses Kubernetes API aggregation layer. It redirects API requests to a separate service, and then then it can be stored in a centralized database from multiple clusters as well, right? So coming to the architecture of the report server. So in a standard case, what would happen is that when you send any request to the API service, all the API requests will go to etcd, and the etcd and API server will handle all the requests like get or create for that custom resource. But when you install report server, what happens is that, as you can see on the right side, um, we created an extension API server, and whenever you push a request for policy reports from either Kyverno or any other tool that uses policy report CRD, it will just contact the extension API service, and that will contact the DB to handle the request, and the HCD won't be contacted, and the API server won't be. Will just pass the request to the extension API server. So it improves the performance by offloading the load to the extension server, and thus improving the performance of the cluster. Right. So now let's see how all of this actually works in code. So let me share a different screen for this. Um, so the screen is visible, I guess. Yeah. So here I have a empty cluster, and what I will do is that I will install report server in this cluster. So what I'm doing here is I'm installing um, Nirmata's enterprise report server in this. Most of the things that I will be mentioning in this demo will be possible in the open source version as well. So yeah, so I just run the helm install command, and it will install the report server. Let's just see. So what will happen is that it is creating API services. So right now, what it did is that it created two API services, one for the upstream policy reports as well as Kyverno intermediate reports, and soon it will be ready and the endpoints will be filled as well. So I think it's getting, yeah, so it's creating endpoints and then it will just start working. So what that does is that, so, so what we're doing in this is that we're creating uh, so we're basically creating a service that is under the hood. It's using what's the- it is using this deployment, which basically like contacts the database, and then it just takes the request from the API server and just passes it on to the database to handle it, right? So for the database, we are using a stateful set that creates a Postgres instance, and that Postgres is then contacted by the um, deployment, right? So it might be ready for now. It's still loading, so the report server will need to get the endpoint. So now if I get the API services, you can see that it's available, and now every single request that I create for policy reports, it will go to the report server service, and it will be stored in the database, right? So let me just create a test policy. So here I created a test policy. So I created a test policy and default namespace named test, and if I just exec the pod, um, and so this is the pod that I created to store that, which is a database which is used to store the reports. And if I connect to the correct DB, so all you have to do to set this up is just create a database inside of your Postgres instance, and everything after that will be handled by the report server itself. So it will create all the relations for you. Right now, it has created two relation for ephemeral reports, which are Kyverno's intermediate reports, and also two relation for policy reports and cluster policy reports. Right. So I created a policy report here, and if I select from service, right. So as you can see, like I had one policy report here called test in the namespace default, which is same as the one, like name is test namespace as default. So basically, it is fetching all the policy reports from the Postgres database instead of etcd. And one more advantage of this is that now you can use complex SQL query to fetch your policy reports as well. So you can just run any type of SQL query that you want, and that is also an advantage of you that you will that will be very useful to you if you have a lot of policy reports, right? So that's how it works, and you can also install it in multiple configurations, like in memory and manage, which we'll talk about later. But yeah, that's what we had for the demo. Um, Yeah. So let's talk about how this works, how this helps HCD in practice. So we did some load testing using Kyverno and the report server, and here we have the number when we install report server and when we do not. So what we did is that we created a cluster and installed Kyverno PSS policies, and we also installed Kyverno at version 1.12.3, and then we just added some workload to see how the size of etcd changes, right? So here, in case when we are not installing, when we haven't installed report server, what happens is that when you have 1200 policy reports, the total size of etcd is 71 megabytes, and when you have 4200 reports, it's 150 megabytes, and at 10K it's around 255. But when you install report server, what happens is that at 1200 it's 38, at 4200 is 55, and at 10,000 is 76. So the difference is huge. The difference is like this because the ephemeral reports and the final policy reports are stored in the database and not in Postgres, so they don't take up the space, and that contributes to all this difference. And one more thing is that when you will create a large workload, the response time of the API server will be better because it's not processing the request for policy reports. It's just offloading it to the report server, and it is only processing reports for the workload that you created. So it will be much faster, right? So now let's talk about the recommendations, and I will hand it over to Anusha.
Anush, I think you're muted. Can you?
Yeah, thank you.
Yeah.
Yeah, thanks, Vishal, for the demo. Uh, so we saw that, let me just go one step behind. So, we saw that when we have report server installed with about 10,000 policy reports, the total HCD size still remain 76 MB, and, without report server, it was almost 255, 300 MB over here. So what does it mean, right? Like, do you mean to say if we should I install report server only after I reach certain scale or only after I start seeing certain issues? Well, definitely not. What we recommend is um, not just report server. Just to tackle this issue, the Kyverno team has constantly been making fixes, enhancements to the way reporting itself is structured in Kyverno. So we always advise to use the latest versions, always keep upgrading to the latest versions. And the report server itself is available in Kyverno 112, and the latest stable release of 112, which is 112.4, was released earlier this week. So the first recommendation is always to keep up to date with the latest versions. But now coming to report server itself, now we just saw a demo where Vishal ran the Postgres server within the cluster, right? But now, suppose say you want to run report server in production, how do you do it? Because managing a in cluster Postgres can get hard, and it is definitely complex. And if you're in a production environment, there's a lot of things you need to take care of if you're running a database within the cluster. So what we recommend to our users and our customers is to use an externally managed database if that is feasible for you, because it is scalable. Now you can use a single database across different clusters. So otherwise you have to deploy a Postgres instance in every cluster. But now you can, if you're using an externally managed database, you can make all your policy reports right to the same database. It is scalable in the sense, at the time whenever there is load or some spike going on in your cluster, you can easily increase or decrease the replica counts of these instances. It is reliable, and these externally managed database, usually like say a cloud provider database, they have high guarantees on fault tolerance, and all other SLAs and guarantees that the cloud providers provide. It is performant and also secure. So you can be assured that all of the data stored is encrypted, and it is a big relief when it comes to maintenance. Because suppose say you're running something within the cluster and there is a CVE patch that was released. Now you have to upgrade your report server, you have to upgrade the cluster that is running, and so on. But If this was externally managed, usually in organizations, either there is a dedicated database team who is managing the database for you, or your cloud provider does it for you. So all of this maintenance overhead is suddenly not your problem. And definitely you can get support in terms of, because not everybody is familiar with using databases on a day-to-day basis, so you can get support as well if this is an externally managed database. So this is definitely a recommended configuration if you're running report server in production. But we understand this is not always feasible. And if you want to run locally, right, like you wouldn't want to connect to an external database every time. So what do you do then? So if you want to run in a dev or a sandbox environment, what we recommend is to use an in-memory database. So you can configure the report server such that it's not going to install any Postgres server, not trying to connect to any external database, but instead it will store all of these reports in memory. It is definitely cost effective because there's no database involved. It is simple because you don't have anything else to manage. There's a small memory cost that you would have to pay because there's a small overhead because you are now storing these reports in memory. But from our test, what you've seen is that's a very small price to pay, compared to the returns that you would be getting in terms of cost effectiveness and the simplicity of it. And of course it's flexible because now you're able to run your tests, or if you're developing new features or trying to do different things with the reports, it becomes pretty quick. And again, it's an in-memory database, so it's, say, a key value pair, so the querying is faster. You can try out different things, you can prototype quickly. That's why we recommend using in-memory database configuration if you're running in a dev or sandbox environment. Now, this can also work for production if you have the appetite for downtime. For example, say the report server goes down, there's a small amount of time it takes for it to recreate the reports. So if you have the appetite for that, then sure, you can go ahead and use this in production as well. But generally, the recommendation is to use in memory in a dev environment and externally managed database in a production scenario. But again, totally depends on your appetite, use case, needs, and so on. So yeah, so these are some general recommendations, but depending on the situation you're in, the guarantees that you want, feel free to reach out to us, or even make the choice of sensibly. So winding up, I just want to summarize what we saw in the last, say, 30 minutes or so. We started with what is the policy report API, why it is needed, and we saw how different open source projects, even enterprise projects, use this API, and what are some of the challenges you may encounter if you have large clusters or busy clusters. And we went through what is API aggregation in Kubernetes, how we made use of this capability in Kubernetes to introduce or develop report server. We went into the architecture of it, how it works. So how Vishal explained, it's a very simple diagram, but sure, there's too much, the complexity that went under it. And we went through how to configure report server if you want to use this in a production setting. With this, I'd like to open for any Q&A, but these are some of the references. So if you want to, report server is a sub project under Kyverno, so it is open source. So if there are any good first issues or you want to learn more about it, we have linked the GitHub repo link. There are different guides associated: installation guide, migration guide. We are available on the Kubernetes and CNCF Slack channels as well. There is a weekly contributor meeting. Vishal, being a maintainer, probably you can talk more on how people can involve in this project. Vishal, are you there?
Yep. Yeah, so I see there's a question in the chat. So so Alan asked that what is the primary method for viewing um, data from the report server. So you can view the data from the report server in the same way you would have done if you could have done in like using kubectl. So basically, what you can do is you can either use kubectl or you can use Kyverno's policy reporter, which would also show you all the compliance information there as well. Right? So any plans to support other database or so. The reason why report server does not support other databases at the moment is that it uses JSON-B to store policy reports, and all of the different databases have slightly different schema for how they represent JSON-B, right? So that's why we started out with Postgres, because Postgres is considered to be a standard, and it's really stable, and it has the highest amount of support if you want to use it in Kubernetes. But like eventually, we will add support for other databases as well.
I think there's another question on, is there any offered GUI web frontend to view the data? So there's an open source project called Policy Reporter, with which you can view the policy reports. But again, there are again enterprise solutions that Nirmata offers that you can use to view the policy report data as well. Yeah.
Hmm. So yeah, I think we had three questions from the Q&A, right? Okay, so I think I can also add up some few questions. Okay, so assume that a person is like who is using Kyverno. So is there a prescribed way to like migrate to using the port server?
Um, yeah, I can answer that. So when you, or let's say you already have Kyverno installed in your cluster, what you can do is you can just install report server, and it will just take over all the API requests for um, from like etcd to itself. And but in case you already have the CRDs for policy reports installed, what you will have to do is you will have to manually install the API service. That is because when you install the CRD for policy reports, that will automatically create the CRD. So that automatically create the API service, and Helm won't be able to replace that. So what you can do is you can install report server without the API service, and then you can manually install the API service with the correct configuration. We have guides for migration on our repository as well.
Okay, great. So again, talking about like as folks were also mentioning of the database, right? So like the obviously there are a lot of folks who are not expert with database, right? So is there any support available for running database or report server?
Um, yes, definitely. So again, going back to how you want to run the report server matters. So if you configure to run it in memory, then you require no support at all. But if you choose to even run it in cluster like Vishal demoed or an externally managed database, um, yes, you might need support depending upon your expertise and proficiency in dealing with databases. If you're using an externally managed database, like you might receive support from cloud providers, and also like if you're using an enterprise version of report server itself, depending on the contract with your provider, you can receive support that way. Yeah.
Okay, so yeah, since it's a new component, so it is like yet another component to monitor. So what if the report server crashes? So that's a important one. Like, what if the server crashes, and how can I recover that?
Right. So in the standard configuration, the report server stores all of this reports in a separate Postgres database. So even if the report server crashes, the volume that the reports are being stored in, it will still exist. But in case both of them crash, like the like the Postgres instance as well as the report server, Kyverno can regenerate the reports, and since report server is used to only store current data and not storing information, Kyverno will like can restore all the reports. Doesn't matter how large your cluster is, like in around 4 to 5 minutes. So for a small cluster, it will take a few seconds, but if you have like thousands of reports, it can be done in under 5 minutes for you as well.
Okay, interesting. So yeah, awesome. So yeah, so I think my questions are like yeah, I'm done with the questions. So yeah, folks, if you have any questions, feel free to like ask your questions right now. It's your time. Okay, so yeah, you also mentioned about like how you folks can also involve, right? So any links, something you can
Yeah,
share with us? Maybe you can share it us with the private chat. I can share it
yeah,
to the
sure.
or something.
Yeah, I can. Yeah.
Uh, projects to. So I don't think this topic is fair. Uh,
Yeah, Vishal, do you
oh
want to talk about how people can get involved in the project?
yes, I think that would be
Yeah,
easy.
sure. So you can, if you want to get involved in the project, you can pick up some issues that are already present in the report server issues, or you can join the community meeting or reach out to me or any one of the maintainers of Kyverno via our Kubernetes Slack channel, and we would love to help you. Or if you have any suggestions, we would love to incorporate them in report server as well.
Okay, I've already added it to the chat. Let's see. I don't think we have any questions left with that, so I hope folks will like reach out to you, Vishal, and yeah, obviously, actually be a contributor of the project. So yeah, so so I think we can wrap up the session, right?
Yeah.
Okay, so thank you so much, Anusha and Vishal, for giving your time for this awesome session. So yeah, thank you so much. See you again. Bye.
Thank you. Thank you for having us. Bye bye.
Yeah. Okay. So, thanks everyone for joining the latest episode of Cloud Native Live. So, we enjoyed the interaction and questions from obviously the audience. So thanks for joining us today, and I hope